Here we are again, trying to wrap up some of these different concepts we have about exponents. And in this section we're going to divide monomials. So if we want to take, remember b to the fifth power means b times b times b times b times b. Now keep in mind I'm only going to ask you to do this one time, so we get to come up with the rule right away then. And b times b for the denominator. Now you know that if things are being multiplied, that means they're factors. Okay, if they're factors, what I can do is I can start to divide them individually. So a b divided by b becomes 1, b divided by b becomes 1. So all that I'm left with is b to the third power. What's actually happening with 5 and 2, what operation do you have to do with 5 and 2 to get 3? Alright, so it's actually 5 minus 2 to get 3. So if you have the same base, remember base is the b term here, if you have the same base and you're dividing, you want to subtract the exponents. So if we have m to the 7th and we have m to the 1st, 7 minus, I always use this division bar and tell myself minus because it looks like a minus sign, 1, so m to the 6th, and 5 minus 2 because I have n and n for bases, so n to the 3rd. So what's the rule? So what is the rule for dividing monomials? So if I have the same base, and you divide, subtract the exponents. And we'll give ourselves another example. So if we have x to the n power over x to the mth power, we're going to give ourselves x equals n minus m. Right, I'm going to go in that order, n minus m, n minus m. So that way everything's completely laid out if we want to see it in proper format. Alright, let's continue to practice. So if I have x to the third divided by x squared, so 3 minus 2, I have x to the first power, or I don't have to write it at all. And I see I'm going to have y. So 7 minus 6 is 1. So I could write in 1s, or I can leave them off. We understand that's the same thing as x, y, all by itself. Now where some people start to get tripped up a little bit is we're going to throw some coefficients in each monomial that we're dividing here. So if I have 81 divided by 9, don't start subtracting here. This is still 81 divided by 9, which is 9. And then take care of the rest of the problem the way we've been talking about our variables. So if I have a and a, so I have 8 minus 5, so I have a to the third, and I have 3 minus 1, so b squared. So we're going to try this next one. We're going to have 3 of these. We kind of use it as a lesson quiz. So when you come in, I'm going to ask you for these 3 answers. So here's number 1. Keep in mind you want to divide here. What the heck, I'll make up some new ones. Yeah, let's go ahead and divide. So 64 divided by 16, it's going to give me 4. 2 minus 1 for g's is g. And 7 minus 5 is h to the second. Very good. Alright, now we'll treat these the same way. So I have 3 divided by 3 is 1. I have m to the third divided by m to the third. So I have m. 3 minus 3 is 0. And I have n to the third divided by n to the second. So n to the first. Alright, so we know 1. Now what was that rule? We had an old rule here. Anything to the 0 power is 1. Good. So 1 times 1 is 1. 1 times n is n. So final answer is n. So what happened to the m? Okay, it became m to the 0 power, and anything to the 0 power is 1. One thing we have to review, because everything we've done so far has worked out very nicely, that we ended up with a positive exponent. But we can do the subtraction and end up with a negative exponent. So a negative exponent means that you move the base to the other side of the fraction and make the exponent positive. So if I have a to the negative n, remember this is over 1, just like we show here. I'm going to move the base to the other side of the fraction, which can only be down now, and make the exponent positive. If it's down, a to the negative n, I have to move it up and make it positive, and in this case we would drop the over 1. Okay, so nice little review. So here's why. Because as I simplify, you cannot have negative or 0 exponents in your answer. Well, we know this part right here, anything to the 0 power is 1. So I don't need to do anything with that at all. So I'm really just dealing with x to the negative 4th. Remember, that's over 1, so my final answer should be 1 over x to the 4th. Alright, let's make sure we have this idea. I'm dealing with p, and I'm doing negative 7 minus negative 5. And here's the only thing that still catches some of us, this double negative. So remember, that's plus. So p equals negative 7 plus 5 is negative 2. Oop, not equal. What am I doing? So p to the negative 2nd. Remember, it's over 1, so I need 1 over p squared. Alright, and 3 over 18. Now, obviously, we have some things changing here. So 3 over 18, well, I know 18 divided by 3 is 6, but 3 over 18, all I can do is reduce it and make it 1/6. Now we'll take a look at the r's. So 4 minus 3, r to the first power, and s, 2 minus 4 is negative 2. Alright, there's a couple things we need to fix in here. Well, one in particular, I can't have a negative exponent. I don't really need to write this 1, so I just have r in the numerator over 6, and s squared, because it has a negative exponent, is going to move down and become positive. So if we continue with that idea, I should be using x to the negative 3rd minus 4. Well, that's x to the negative 3 minus 4. So if I borrowed $3 and I borrow 4 more is negative 7. I now owe you 7. Remember, this is over 1. So final answer 1 over x to the positive 7th. So we're going to continue to combine all these rules, and we'll practice them somewhat in isolation, and then we have to break them apart as needed, because that's when it really gets tricky, and that's what we're really going to do through the rest of Algebra 1 as we make the problems a little more difficult, and into Algebra 2 and beyond. Alright, so R's and S's. So negative 5 minus 3. Negative 5 minus 3 is negative 8, and negative 2 minus negative 3 is positive 1. So my final answer is s to the 1st over r to the 8th. Keep in mind, the only thing that is negative is the r, so that's the only part that's going to move. And it's only going to move because it's a negative exponent. Alright, now like we said, we're going to combine a couple different rules together. So here we go. Before I can do this division, I have to take care of these exponents out here. And to take care of these exponents, what I have to do is distribute to each of these terms inside. So power to a power means I'm going to multiply. So first thing is I have x to the negative 6th, right? Negative 3 times 2 is negative 6, and y to the 4th over 4 to the 3rd. Well, 4 times 4 is 16, and if I have 16 times 4, I have 64, because this is 1 times 3, so 4 to the 3rd, 64, and x squared, we'll distribute here, x to the 6th. Alright, everything that's going to stay put will, well, is my 64, my y to the 4th, and then what's going to happen here? I have x to the negative 6th divided by x to the 6th. So negative 6 minus 6 is x to the negative 12th. Well, if that's a negative 12, I need to move that as well. So we'll have y to the 4th over 64x to the 12th. Very good. If you followed that, you're doing real good. Alright, here's another one to try like that. So first thing you have to do is distribute the square. Keep in mind that negative 3 all by itself is to the first power. So if I want negative 3 and we're going to square it. So if I square negative 3 times negative 3 is 9, x to the 4th and y to the negative 2nd. We have some similar work to do down here. Remember, this is 2 to the 1st and x to the 1st, so distribute, distribute, distribute. 2 to the 3rd, x to the 3rd, y to the 9th. Let's start to clean some of this up. I know this is 9, and 2 to the 3rd is going to be 8. Next thing we start to do is our subtraction, so 4 minus 3 is x to the 1st power, and negative 2 minus 9 is y to the negative 11th. So it looks like we have some things to move around. I have x and 9 are going to stay put, 8's going to stay put, y to the negative 11th, see you later alligator, going downstairs, there you be. Alright, let's combine this in with our scientific notation. Now, the last part for the day, not doing anything new, you already know how to do most of this anyway, so when we multiplied we did two separate parts. When you divide you can do the same thing. So this part you're very familiar with, 10 to the 13th divided by 10 to the 7th, well that's 10, 13 minus 7 is 6. And prior to that we have 5.2 divided by 1.3, and it's going to come out to a nice even 4. Now 4 is an acceptable number, so that is my final answer. Alright, so we can always kind of do the times 10 first. So negative 10 minus negative 6, well that's negative 4. Now in scientific notation, it's okay to have that negative exponent, that's alright. But I do have to do 3.6 divided by 9. What we're going to get here is 0.4. Oop, lost my pen there. 0.4. And we have to remember is this is too small, right? It has to be between 1 inclusive and less than 10. So if it's too small by one place, small, subtract. So 4 times 10 to the negative 5th is now what we're after. Alright, and again we can take care of our times 10 first. I have 4 minus 6 is negative 2, and we'll do our division here. And we're going to get 1.3. 1.3 is acceptable, so that is our final answer. So we're going to combine the two rules. We can see how we're going to apply this to scientific notation and go from there. Alright, what I'd like you to do is try these last three. Remember, you're going to treat this separately. Do your regular division and then use your subtraction of exponents. Same thing for 28 and 29.